Hello and welcome back to the stream. I am Junchan and we are back doing some Purescript. And yeah, last time we got to get back to Purescript React Explorer and sort of add some of the stuff that the later implementation of Arthur Xavier had added. Specifically, what was it? I think the base monad is what we added, right? Let's, the base monad. And in such a way that we also hooked up the pair, the monad that's the pair of the comonad, but by deriving it as opposed to the choice that I can't really explain, which here uses a arbitrary m instead of using the pair of w. It's a bit strange. Yeah, so that means that with this base monad, we are able to switch what our effects, where our effects take place. And so we can make them run in effect, or we can make them run in AF if we want to. And I think I want them to run in AF, so that we have some asynchronous primitives available to us, and time and delays and things like that. But let's see. What I wanted to do is to think about what are the various ways and pick a way in which we could use effectful interpreters. So is this going to be done through the base monad in handler, in which case in our code it would happen somewhere around here. Let's see. But it's a bit strange because our interpreter is it's outside, right? Our interpreter is here, but then our handlers are here. So our handlers will have some effects, but yeah, I'm not sure how to reconcile this, because this, in effect, I think let's roll it, like sort of think of it, think of walking through this sort of step by step in some way. We display the UI, and then we install a handler such that when we receive a key press, we send a value, and that value is constructed from the current state and then whatever we got from the key press. In fact, it's not constructed from the current state, but it could be if we wanted to. And so we send a value that's kind of wrapped in different ways, and we could trigger some effect in the base handler monad here. But here we're sending a monadic value, which contains the putStirLine monadic value, and it's built in this strange monad. Kept the type around here because basically it's the console W, the console F is, I think, our right. It's the pair of the base monad. So transforming the pair, and that's why it's passed to wrap free. So somehow we create a value that lives in the pair of the base monad, but it's also parameterized by the actual free monad that is, in fact, so there's a square there, which is the square is such that I think that free co-console F, co-console F should be isomorphic to co-free co-console F. So co-free co-console F is the co-free comonad built out of co-console F, and we transform it into the corresponding free monad by putting co in front of it. Here we put co in front of not the monad but the base functor, and that should give us the console F free functor, out of which if we apply free, we get the free monad. But that's, and so I think that there's a commutating square here. Hey Emiliano, the definition of co is let's go find it. I don't know it by head. Co is the same as zap in Haskell. And let's see, I think it will be here. Co here. It's a kind of a Yoneda looking CPS transformation looking thing. And it is such that from any comonad, co of W is a monad. And it doesn't work the other way around. But it's sort of a pretty important result for this framework we're using, comonad EQIs. So co W is a monad whenever W is a comonad. And it allows us more practically here to be able to define only this the base functor for the co-free comonad, and then get the free monad for free. And that's sort of one of the neat things about this whole comonad EQI approach, is that in theory, well, from this comonadic value here, which in my world I understand as an interpreter, we can define the actions that are going to be fed to the interpreter by using this formulation here. We're able to derive a monadic action that corresponds to the put interpreter, like in the traditional console style base functor that is usually used for free monad. We can derive it by with that co constructor, which is part of the co tooling. And let's see, where is it? I don't know if I have this here. Probably should have it, but I think I have it open in one of my numerous tabs. Let's see. Co, it's not here, it's in pairing, right there. Oh, co is just actually the constructor co, so pretty straightforward. Pattern functor. You're the second one that uses this term, and I think it probably means the same thing as what I call the base functor of the free monad. Functor pattern. Where did you hear that term? Because you're the second person that tell me about this pattern functor concept, but I haven't heard of it before. Pattern functor values are tagged with the HTML node type they represent. Is that it? Several I can map to the same pattern functor. Huh. Functor pattern projection into that recursion schemes. Pattern functor. Right, so the F suffixed thing, right? So yeah, so I hear that's an interesting term. I didn't know that term. I usually what I read is the base functor for the free monad, or the base functor for the co-free comonad or something. Cool. That's interesting. I didn't know that was a thing. Yeah. So there's this interesting commutating square, and I haven't seen that being talked about so far. And I'm bumping into this because I get these pretty hefty types because I'm still trying to wrap my head around how all this works. And it seems that here the co-console F, for instance, is the pattern functor for the for the paired free monad that's based on this functor. So co-console F is a kind of console F if we were to define console as free console F, which is the typical thing, right? And the pair of that, which we could call co-console, is co-free of co-console F. But what seems to be the case is that if console and co-console are paired, in fact, console F and co-console F are also paired. So, and in such a way that this thing commutes. And I don't know what kind of result that is, but it's there. So what I'm wondering right now is, where do I put actual sort of bona fide side effects in this framework? Because I'm tempted to want to put the side effects in the interpreter. And when I say side effects, I mean, like IO style Haskell side effects or effect style side effects in Purescript, like things like actually writing to the console and whatnot. In the original formulation by Phil Freeman with Purescript React Explore, it doesn't matter so much because the React component thing is what is meant to be providing the effects. So it's fine if the free monad and the co-free comonad are pure, because your React component is the place where you're going to be doing the side effects of rendering to screen or doing the side effects of grabbing events from the UI at the DOM and whatnot. But I want to modify that. I want UI to be, and console writing or whatever, or network reading and writing, to be only one possible side effects in machinery that shouldn't be biased specifically towards React or any such thing. And the reason the architecture that I'm inspired by to kind of try and explore that is Cycle.js, which does this abstraction of having like a kind of pure data flow graph with sources and sinks, and then wiring that to a layer of drivers that each provide side effects and that you communicate with by just outputting pure values out of your main program and then expecting or consuming pure values that are outputted by your effectful drivers into your pure computation graph. So makes sense. If I've seen the pair described free as a disjunction between label and an effect, and co-free as a conjunction between the label and an effect, i.e. free MA equals A disjunct from MA, and co-free WA is A paired with WA. Right. Yes, and there's this slide from the right there, I think. Yeah, this slide that to me summarizes well the kind of the pure. This is from Phil Freeman that came up with this formulation, and to me the slide that really shows why this abstraction is powerful, because it subsumes the concept of what React does, what Halogen does, what Redux and Helm does, what incremental, which is one of Phil Freeman's approach, does, in terms of the pairing of something that is action-like and something that is more space-like. And their combination is actually this kind of pairing. And you see, I think, some of what you're saying here is, well, maybe not, but something relating in here, at least the pairing between the arrow and the product. But you're saying something else. But but yeah, that's how I think the kind of whole comonatic UI sort of can be summarized in a bit of a nutshell. Right. Good. He does talk in Day, absolutely he does, about Day convolution, absolutely. And did you see today, actually, Edward Met was engaging with Phil Freeman on Twitter about some of the stuff that Ed's been working on lately. Where was that? That's not the one. Right, that's the one. Phil came up saying, "Is Day for combining modalities or something like that?" I think because this crazy error is actually about Day convolution. Wow, he picked that up. Phil actually read through the whole error message and was like, I wonder why Ed is using Day convolution. And yeah, so Day convolution in this framework is, I think, if I understand correctly, is to combine comonatic values, and then it's so it becomes combinators of, let's say, UI components that are sort of like, how would you say, they encapsulate not only their UI but also some behavior, and there's several ways to combine them, and one of them is Day convolution. I've commented this out yet, still for now, but it combines two components, and by doing some kind of convolution of their state space. Yeah. So, and that I think Day of the comonad side of things then becomes the product. Is that, I think, yeah, becomes the product of the monadic values. So it's an equivalent to the sort of the combinatorial explosion of being able to explore all of the product combinations between, like, a component that has actions in a pattern functor F and a component that has actions in a pattern functor G. And so if you make a product of these, of the monadic side of things, then you can see that you need to be able to interpret all of the actions that your product is going to throw at you. And I think that the thing that does this is the Day convolution on the comonadic side. And then there's also sum. And so sum becomes more like the so in practice, Day becomes, you have two widgets on screen, and you're able to treat them as a combined widget, and because you're able to deal with any combination of actions that are that come out of your in my world of the driver or your user. And sum is the sort of more alternation, meaning you have either one widget or the other, and so that's the comonadic pairing of a either in the action space, right? Because I consider this part of the pairing as the action space, where you have monadic actions that sort of are equivalent to making decisions about about interpreting something that happens outside in the real world, and deciding that these are now sort of monadic values. And then the comonadic side of the pair is the state space, and that takes that comonadic value, takes the monadic value, and then knows how to transition into a new position in the state space. And so when your action space is a product of actions, a sum of action spaces, then your comonadic pair is this sum. But this sum, yeah, I think that's right. So I think it takes sums to sums then. Is that correct? I wonder. Because it takes products to deconvolution, but I think it takes sums to sums. That maybe is in this article. Anyway, I'm going to link this article for you because you might enjoy it. Oh, yeah, he doesn't talk about deconvolution in this one. Convolution of the state space. Okay, so let's go back to what I was wondering about where to put the effects. So yeah, if I want to put the effects, there is also a possibility that I keep there is some notion of pure actions and interpreter, and then that there's some lower layer that is actually an effectful interpreter that is sort of coupled to the pure interpreter, maybe, or maybe that means that I would put something that's interpreter like here. Or maybe meaning that the send is going to be, yeah, maybe pushing the interpreter down into the send is something that I already was considering last time. Is that possible? How would that work? Because unfold co-free is pure, so that's one thing, right? The other thing I wanted to explore was unfold co-free T, which in theory should allow to, well, no, right. Unfold co-free T, the problem is it's a transformer for comonad transformer stack, not for monad transformer stack. So I'm not wedging here a new monadic effect of some sorts. You're very welcome. Never written any Purescript. Doing something similar to Halogen once in Scala.js. Hey, right. Nice. That sounds really challenging and interesting. Yeah, I haven't done much Scala. I shy away from it. I'm very attracted by the terseness of Haskell and Purescript. So yeah, I do. I've been alternating between some Purescript project and Haskell project here on the stream, and still very much, an effort to kind of fill in the gaps in my understanding of this whole ecosystem and trying to have toy projects to kind of move forward with that. Right. So this whole unfold co-free T is unfortunately a red herring. I don't think I can use that. So the other maybe piece of tooling that could be relevant here is the whole yeah, no, I'm not sure. Okay, well, I want to actually try to just do it naively and then see whether I can refactor it in something that maybe has more mathematical regularity, or we can find that it's been already implemented elsewhere, as often happens. So what would it look like? I think what it will look like is I will have, well, basically it means that this interpreter, there's a pattern here that is also not abstracted over, which is the threading of state. And I think that's suspicious in my view, that we do have state that's being passed around, that somehow unfold co-free itself actually sort of embed this notion of state. But clearly there's something where we could abstract this and make state something we can plug in and out of this whole stack, because now I think it means now that the interpreter somehow is not just the, I mean, it's a pure-ish interpreter, but it has kind of a state monad embedded in there, because it gets past the state in addition to the action, and it's able to, like a melee machine, I think, able to decide what to do based on its input and its current state. So that is kind of the other, that is a little bit the other abstraction that I kind of want to look at. It's the melee T machine abstraction. Package. And I came across this a few times because it's the same type than the Dunai monadic stream function type. Unfortunately, this doesn't link correctly anymore. Source data monadic stream function internal core, I believe. Yeah, that's this guy. Right, and I was looking at this earlier today, and at this comment in particular, because I was kind of thinking of the Dunai wrapper of like this monadic function, and then the ability to also oh, hold on. Yeah, what Ivan Perez does actually is that in this M, he stacks a monad transformer stack, but he doesn't make a statement about. I think he makes a statement about the fact that if the monads in the monads transformer stack are commutative, then the arrows are commutative, like the arrow instance of MSF then is commutative, something like that, I think. But clearly what I understood this morning is that the reason why Ed specified that melee T has applicative effects, I think, is because an applicative instance of melee T MA, if M is applicative, if M is applicative, then melee T MA is applicative, which is a kind of like fan out effects kind of thing in my mind, like a tree of effect where the branches can't talk to each other. And that's fine, but how does it relate to this idea of plugging in actual side effects like keyboard and rendering and whatnot? That I am not clear on. Okay, let's do what I said I would do. Let's implement something that will allow us to ground this problem into some actual thing that does the side effects we want. And I think we do want to hook this up. I think the first step, if we don't want to refactor the whole rendering part of things into a separate driver, which will be heavy lifting, then will be to hook it up to something else. That's but the problem is that there's this entangling of the React component type and the base effect, but not just that. I think mostly the fact that state and actual actual side effects I think occurring in the React monad. Okay, let me try to make this more precise in my head. We pass effect here, but we could pass something else. That's the kind of the base monad that we use, in fact, really for the handler. And that allows us to actually have effectful handlers. And it also allows us to get effectful values, but this, I don't really know that this is useful. I'm kind of tempted to think that this type is also fine. Right, I think I need to check at the end of the world, how does React, how does our, but that's the end of the world there. This is where we wire a browser event in the React framework to this on key press. It's wired, like the subscription to the DOM happens on first load. And then a handler is registered which contains this Purescript code compiled to JavaScript. So that's the end of the world here. Right, so the problem is going to be that if I want to register something like a network input, which is some of the stuff that we were wondering about in the prototype, which so far, like, we've tried to implement with this swarm, hyperswarm library, and hooking that up with a readable stream that's listening to incoming hyperswarm events. Then the question is, where would we register that? We probably register it completely outside of React component. In our toy implementation, that used this SDOM library, we ended up indeed like registering it sort of at the root, at the same time that we did the attach, which was the SDOM way to sort of initialize the root component. So in the main, we also did the registration, such that we also had like some send and receive. We were wiring. What is it? Send underscore, I think, and yes, those are the actual effectful ones. But yeah, here is specifically where we were a little bit blocked, because there was no easy way to specify, to compose something like an external effect handler with the inner state modification. I think we did find some way to do that, but it wasn't allowing us. Yeah, because we did have a push. So that's the main thing, I think, that we got a push that allowed us to push events inside the component from outside. So we need something equivalent to that. It kind of means that our, like, the top level render here we need to return something that we can interact with. And so that whole entanglement with React is I wonder whether this is really where we want to start from. Maybe we want to start from something that looks like a very basic go-free. We did something that's going to look a lot like my play experiment here, except in the monadic comonadic world. So maybe without the whole Purescript run streaming baggage, but with the effectful interpreter and so on, and then try to get to creating a rendering driver from there. I think that's going to be the easier way. Also, it's going to be interesting to extract the essence of this pattern without the accidental complexity of the React component wiring. Okay, I kind of like that. So it means that we'll devolve back into a I think, do we devolve back into a non-browser app to do that? Does this make sense? I mean, we can stay in a browser app, but how are we going to interact with it? Maybe we keep it on the side and we just console log our outputs just as a start. And then we'll think about how we wire in inputs. So it means that we don't render UIC anymore. We kind of ignore that and we'll just log show hi. And we'll just let that be compiled and built and check that it works. And we'll start from scratch, pretty much. Hi, okay. And so we'll say, well, UI doesn't matter. Cofree example is a kind of a UI thing, and we'll call it Cofree UI. Or maybe Cofree React, because this is entangled hopelessly with React for now. And yeah, we'll change it here, but we won't use that for now. And instead we'll do a whatever, an actual, what was our thing, like a console component. And is it sufficient? Yep. So I mean, this whole thing is indeed, no, it's not agnostic to the UI because it's very entangled to the UI right there. So that's one thing we need to already think about how we want to extract that. Move is completely agnostic. Explore is completely agnostic. No, explore is not agnostic because it includes some notion of, is it sand or what is it that makes it needing to be providing a React component? I think it's just because component T returns UI. So this is not yeah, so there's going to be some entangling to do here. But send, I can see how maybe that's a way to hook in external side effects. Okay, so am I going to, I think I should do a another version of this. Explore Explorer. And it shouldn't be React, it should just be Explorer. And we want to remove that UI, but what do we want to put in there? Maybe we don't put anything. Maybe it's just base. And then base, and maybe calling it base is sort of, no, yeah, it's fine. And then the base might have some UI stuff and it might not. And so if that's the case, then let's save this and let's see how we can fix our types. So first of all, we're not going to return a React element. We will return something in base. In fact, probably something in base CoW unit, maybe, because that would be the value. I think so, maybe. Let's try this. I don't know. Let's see. We were returning a React component, which itself was a component T. Oh wow! So there's this kind of entangled recursion in there that I didn't even spot. So hold on, let's write this in type in front of our previous type, because so that's the type of React component, which is the thing that we return from Explorer, that we used to return from Explorer. So let's put it in here. And then UI, yeah, clearly UI we're going to need to change right there. And what are we going to return? Something in base unit, or unit rather. I think that kind of makes sense, maybe. And then, is this completely redundant? Do we only have, I think it probably is. I mean, maybe we need the CPSing kind of thing, but maybe we call this driver. And so a driver would be something that takes a handler and just returns something in our base monad. And so in our base monad, if we imagine that we have rendering, then we get a handler that receives some action from the rendering monad, which might be like a key press. Like if you say more like it's a UI based monad, it may be a key press. And so we need to pass to our driver, what do we do with the key press? Base might not be the same, right? So it's kind of maybe driver and base. Maybe there's a driver monad, and I receive an action in the driver monad or return in base, and that actually functions in driver. Does it even make sense to make a difference like this? probably doesn't. I think it makes it more complicated. I mean, here it starts making sense because I was liking the idea of having just an action returning in the base monad, because it seemed like the handler would plug into the pure world, so it would receive a pure action, and then it would know how to return something effectful. Maybe just in the driver monad, and it's just up to the driver to decide. The driver has its own set of effects, and it might be a monad stack. Yeah, no, but then you need to think about how you combine the drivers, right? And this might be the driver stack. So maybe we call it a stack. And then because we know that there's going to be something composed here. Meaning it's going to be a kind of a monad transformer stack, maybe with a effectful effect monad or AF at the bottom. But we're going to need to think about composition of those things in a way that's a little bit orthogonal about how we're going to wire our components and even our drivers. Yeah, this is all the question about driver composition, and that's a bit complicated. Because it implies things like ordering of effects and whatnot. So another way to ask the question is there a single driver with a whole stack of effects? And then we punt the how do we build drivers question in a way that's composable as much as possible with the constraints, or do we try to make this interface already right now composable? Yeah, I think we don't. We consider driver as a monolithic thing, and so then we're back to kind of this, and then maybe it makes sense to kind of call this driver, because and then it's just that we have only one. Okay, so then a driver is something that then is something that you use to build a component, or your components, they might, yeah, right, the way that we compose drivers might be extensible effects, in fact, here. But component T might be depending on a row of drivers or something. God, that makes me wonder whether, in fact, this whole play thing, which uses extensible effects on the get-go, really is, in fact, what I want to start from. Because I already used the essence of well, I actually use only one part of the benefits of having the free pairing here, because I built the free monad manually. And then I have like all of these nice low-level things. Including the composable effects, even though it kind of creates, there are some things that I haven't quite solved there, I think. But it is further forward than what I have here. There is a chance, though, that by starting from here, I will find patterns that corresponds to moving and sending that would actually make this code prettier. Because this is very pointwise. And there's not a lot of regularity to it. I mean, the base monad, and I think maybe I hadn't quite yet also thought about exactly what we're looking at, in fact, about what a component is precisely. So maybe the component nature of things and the ability to do deconvolution and sums and whatnot. Maybe we can keep that mathematical structure by starting from there and then progressively add the Purescript extensible effects like in the driver side of things. Because I probably wouldn't be able to refactor my crazy code with this kind of more simpler interface, because this is not actually simple, but at least it has the benefit of having been thought of with the idea of doing things like deconvolution on top and whatnot. Okay, I've convinced myself this is the right way to go. Okay, so so it's not a UI anymore, it's a driver, and it does this. Okay, and then what? And then what breaks as a consequence of that? Well, we don't have a UI effect anymore. Indeed, we have driver, and well, those are our base as opposed to drivers, but I think we can live with that. And is that sufficient really to make the code compile? No, it is. Holy moly, what? Ah, damn, I'm in the wrong thing now. So maybe there's still an error here. I just need to hit this here. Right, okay. And okay. Yeah, so the main way in which this code has changed, apart from basically renaming UI with driver, is that I removed the driver monad from here. I could add it back, which changes where the type error occurs, because also the thing that I didn't re-add here is that, right, what is a component for us? It would be component T effect. Okay, so it would be component T base W. What? Hold on, how does this expand here? Why is this broken now? Oh, it's not broken, it's just a warning because I don't have an M anymore. Okay, R React element. Oh, R is actually React. Okay, right. So yeah, I was R.React element is not React element. Like the naming of these things is mental collision prone. So it was totally not that type here, not that type, therefore not this, but instead I suppose the driver units. I suppose that this should do, right? So base unit, but let's call it driver here. Variable unit is undefined. Unit, yes, unit like so. And then the variable base is undefined. That's right. And then it just works, which is nice. But then I can also revert back to the old thing where there's no driver here. And I don't quite know yet whether I want that or not. What does it even mean to receive an effectful action? It could mean that we receive a handler, for instance. In AF or in. So maybe we do want it. Okay. So let's leave it there. We already upgraded the code to allow it in any case. So now we have an explorer that can work in any driver, so long as the driver is a monad. So let's see what that means with our example. It means that this is a what? So this React component is a component T effect, right? So this would be a component T effect, and the co-monad is co-free co-console F. And similarly to what we had before, it will also unfold co-free, I believe, but UI wouldn't be a UI anymore. It would be some driver, and we'll have the interpreter. And we'd start with an empty state. And our driver would be something that would take a state, so we say it's a string, and by doing that, indeed, we haven't abstracted the state monad, but maybe that would be a nice next step to do, to try to put a state monad into driver. See whether that we can manage that. And so instead of returning a React UI, what do we return? Well, we return something in the driver monad. But what is this driver monad? We haven't defined it. We need to define one, I think, is the point. So we'll have a driver, or let's say a we'll call it like the what do we call it? We call it my driver. And we'll say my driver is supposed to be what? It's supposed to be of type driver of some driver monad right, so no, it's not exactly, I'm not yeah, what we need is the lowercase driver, right? So well, shall we start with just identity, in fact? If it's not identity, then we want to start with it being effect. Oh, well, right. Actually, it is effect. If we have a component W. So let's do that. So let's have just a component. And then what? Then we return driver, and we know what the driver is. It's effect. But is that really what we return? What was React UI before? It was UI effect. So yeah, it's right. And then what? An action, right? So the action, well, it's indeed, it's that crazy thing. But you know what? Let's be nice and let's write a type synonym, because it's really, that's really console. That's the it's really, no, that's console unit actually. So so console is Coco free console, and so then we buy ourselves a nice console unit here. And of course That's like so. And then, well, string is our state. And then we get like this event hook in the exact same way. And then if we're in effect, then we console log, or no, we don't console log. What am I saying? Yeah, right. So if we're in effect, then what event handlers do we have? Do we have any event handlers? Well, we are really secretly in the browser. I suppose we could use a timer or something. Because we can't read line from here, unfortunately. We're not in an easy way. And we don't want to use the UI. So timer it is. So then in truth, we would want this to kind of be extensible and carry timer in some ways. But we'll be simpler, and we'll say just give me some timers, Purescript, please. JS timers might be cool, but maybe a simpler timer if you have one. Maybe there aren't simpler ones. So that's connected to RxJS, that's connected to FRP. Right. Yes, that's something I do want to explore. I should put it in a note. I do want to explore, could we use the frp.event type like Halogen does? Okay. And if we don't, then we'll use probably the JS timers one. And for some reason it doesn't appear here. So let's just go back to our search results. And we have, well, let's indeed Spago install the things. Spago install JS timers. And then let's see how we're going to use that. Effect timer. We're just going to do set timeout, and or maybe set interval. That would be nice. So let's import that. It's in effect timer. Let's put it in effect. Let's be nice and orderly. Import effect timer, and let's use set interval. I'm going to need to Spago build, aren't I, for my IDE to pick it up. And then what? So we return something in that driver monad. Which is really just waiting for handler returning something in effect. So really the hidden type of this is string to handler, or so therefore to effect unit, no, effect console unit to effect unit. So we get the state, we get the handler, and then we just say, well, set interval milliseconds, right? Yeah. So every second, well, that I suppose is where our wrap thing comes out, right? Well, we kind of want to use send. Oh, that's not right, right? It's not right. Send is this. So we can set interval if we want. Well, actually, yeah, there's different meanings for this. Either a new action could trigger a new set interval, or we could set an interval and then well, okay, for we don't care about what's returned, and we pass. Where do we pass to send? We pass some console unit, and maybe right. We pass some monadic action, which would be like something like put stir line. So, except that we want it to be in, and in fact, we can now, I think, rewrite this, by the way, as val string. Still need to be, in this case, called console f, but here this is console unit. And to send, we need to pass like some effectful value. So really, we're going to just lift something in console unit and right. And this is in the base monad. So that's the thing we could do. We could just lift those things as well. We could have a put stir line. Could try to write one that is string to console unit. And what would that be? Can we type whole always through it? It is not Haskell. It's not going to be as good. But put stir line f. What's a here? You're not going to tell me. Is it because I haven't completed this? Oh, it is. So let's say pure unit for now, right? Let's this should be a fine value. And right, okay, no my driver anymore. And you don't know type driver. Yeah, that's right. It's because I haven't imported my new fancy Explorer thingy. Port Explorer. And then there's going to be probably some collisions. So let's import it qualified. And then that's and then let's say that this guy is explorer.component and this is explorer.driver. And I think that's pretty much it, right? Sorta. Okay, I don't want those errors. Oh no, it's not. Wow, it's type checks. Okay, amazing. It type checks. So hold on. So then, oh no, it probably doesn't. I'm just type checking the wrong thing. Yeah, no, good. Okay, wow. Unsafe course, no. Okay, so we're right. We want str here. And maybe str here. And now well, something that take this string to co-console unit and then get. So I think this is the unwrap. This is what unwrap does, right? I'm pretty sure. Or no, it's not unwrap, it's wrap free. This is more or less what wrap free does, I think. Except we want type unit. So what's missing? Yeah, here for some reason we have to do this. Do we have to do the same thing here? I think we might have to. We do. So it's just as simple as that. And then if we do that, then we don't need to use the other guys even here. We can probably just use, in this case, pure put stir line. But let's do it here. And we want to put stir line something like well, like state, for instance, right? So if this is 1 and we put stir line state, and this is not going to associate property, and this is not quite right. Okay, so that was right. Oh, but right, we want to send this, not just and right, this is F now, and this compiles. And so does this mean we have a timer running in our example? If we reload this, well, we might, but we haven't hooked it up. That's the thing. We just lock show high right now. So we need to probably like do something like void, but yeah, how do we run a component? What am I doing? I'm lost with my keyboard shortcuts is what I'm doing. And this, so can we execute that? Or we can't. Why? Because it's a co-free console blah. So how do we run such a thing now that doesn't have a React component as a driver? Oh, right. So, so we passed it to the render of the React framework, which takes a React element and an element which is the where you attach it, and then an effectful thing and return some element if you need it, and does all the wiring and whatnot. Oh, right, to React. Right, that's the thing we need to transform. Okay. Yes, exactly. So it's explore already. That's what it is. So do we have one of those now? We do have Explorer. So Explorer.explore will take some stuff that we want. It will take a community driver. It will take something that writes, and in the case of React, it was it was the state stuff. Well, we can do like identity or whatever. Okay, so this is supposed to be something that writes. So I suppose there's like an actuator. And the way that actuators and sensors are wired in this framework is very asymmetrical. Because here in the React implementation, you do have to use like the React state, the actual React component state, in order to persist. I think basically persist the, or even interface with the React component by passing it, I think, the result of the comonadic space value, like the result of extract on the comonadic space value. So it's not really an actuator. It's just an adapter, a way to. It really is it is a coupling point between the component state tree and the React state tree in some sense, I think. So then here we could have something that does similar. Well, do we care about, do we care that it's state? I think we shouldn't care that it's state. I think we should consider it still as sort of space. Like, so maybe it's a way to hook up, maybe this will evolve to be a way to plug in different part of the space to different drivers, or different part of the driver stack, maybe. Okay. But for now, it's just going to be sort of like some pure identity-ish thing. And this needs to be explorer.explore. And then we need the kind of like sort of identity, sort of. It's not gonna work. I think we need pure identity or something. Or maybe const. Okay, we need something that takes this crazy thing. Wow, that's much more than I thought. Hold on, why is there so many things? This takes this and a componency driver, and we have a componency driver, right? That's one of those, right? Oh, componency effect. Ooh, hold on, did I mess this up? Oh yeah, no, of course. I think this is going to bite me in the ass. I think driver, I think this is wrong. So maybe stack, or maybe just M. But M has the trouble that this is not the, it's not the pair. So base, well, let's go back to base, really. I think it was a smart name. Okay, it's kind of a base monad, maybe. Okay, and therefore let's recover this here. And you had not changed it further below. And this should yeah, make things easier to reason about. Okay, what do you tell me here now? Right, so you want a co-free, co-console F. So you want that kind of monadic value. Okay, let's. This is hard. I need to look at how write is implemented here. Write takes a S, which is a comonadic state, and then returns just an effect unit. Yeah, no, there's really nothing. So it's, yeah, there's nothing to it if we want to, you know, do the trivial version, which is just pure units, I think. Yeah, okay, this compiles and no timers. I think because this should be pushed at the end of the world somehow, I think. So let's try and trace this mentally. We get explore. Oh, well, yeah, we are doing kind of nothing here. So it means we're not doing anything with the state that's being passed to us. So maybe if we were, then we would see this moving, but this does nothing to the state, our send. No, it does the put stir line state. Right, so this is the confusion that I've experienced before when trying to play with this. Oh hey, Ujval420. Can you explain me closure and lexical scope in JS? I believe that my understanding of that is very shallow, so I'm afraid I wouldn't be a good person to walk you through that. As you can see, this is not JS, this is Purescript. It does compile to JS, but yeah, I have some sense of what a closure is in general in any programming language. But I think your question is very specific, and I'm afraid I wouldn't be able to help you so much. Okay. So yeah, I've experienced this confusion before because now we sort of have two channels to do things that feel a little bit effectful. One where we just sort of arbitrarily, maybe like an escape hatch kind of way, just benefiting from the fact that we have the effect monad in our stack somehow. And then the other by being more principled and sort of putting things in an interpreter, which connects to this whole arc of where I'm trying to go. And yeah, in the previous way that I've solved this is by having an effectful interpreter of the form such that the carrier type for the comonadic value was effectful in itself. And I don't know whether that pattern is sensical or not. But here I suspect I actually need to do something with the state that comes in, and in fact I need to also think about whether I need to return something that actually has some impact. At the minimum, I should maybe log the output, because that's our only way to actually know that we're doing something. I'm curious about profiling here. Is there some kind of infinite loop going on or not in the background, or timer based thing? There is a, well, we don't know whether there's a timer in there. It's hard to tell. There's some minor, yeah, we need to look at either the call tree. There seems to be something coming up once in a while. Is that, it's not every second though. Yeah, show me maybe what you got there. What's up? Why am I not normal to have tooltips here? I do not know. Normally there are tooltips. Maybe in JavaScript there are tooltips. In Chrome there are tooltips, but not here. That makes it quite hard to use. No idea what that is. Yeah. So let's get rid of that. Let's go back to our console and let's just log our state. But then we kind of know. Well, no, yeah, it should work actually. We'll log our state, and then it means that each puts the line that's in that set interval should output state, so it should output 1 every second, because puts_the line is going to do the pure modification of state, and I think that means that, well, it means that we need to fetch it from S. I don't think we can basically S is not going to be a string. S is going to be a common-adic value. So how do we get the state out of a common-adic value? We extract, probably. Let's try that. Let's log show of extract S. And we need to extract from commonads, control commonad, and okay, so the commonad has this crazy type, effect of blah to effect of units. So that looks like the handler. Why do we get a handler here? Write state this space S. Not very helpful. How about here? Write move space M. So this is our write function. And write will be applied to move space M. And move space M will provide a value in the commonad, but with A as the carrier type. Right. But our carrier type is this crazy thing. Right, we have a... No, not this. What does it say it's getting from an S here? Saying that extract S. Okay. Let's just see what the type of S is here, just to check. The type of S is co-free, co-console, F of a T2 unit. So when we extract, we should get that T2 unit, but the T2 is pretty unwieldy, because that T2 ends up being okay. Maybe there's a parenthesis problem actually that I didn't spot. Right, maybe we don't need, in fact, to create a pure unit at all. No, we do get that crazy thing again. So why is S, where is the S carrier type of function? Is it because it's a co-frequenmonad, so when we extract, we don't directly get the value? We gotta pass it ID or something. Okay, we need to be a little bit more principled about this, because I think it's sort of the symmetric of this. Like you can't use the values directly. You gotta unwrap and wrap them in some ways. Let's see. That thing is actually double CPS also. So that feels like co. Yeah, check this out. It's just really what Explore expects. It expects that crazy thing. So we do need to find a way to unwrap. So either we try to ignore the value of S, and that doesn't work because we kind of, this is really W, and we want to get to an S. So we absolutely need to learn how to do that. So looking back here again, this passes to explore like a right state, this and space S. This looks very uninvolved. It just somehow serializes the monad, the comonad in some sense, and passes this to as a state to the component, to the React component. And I wonder how that helps with this pattern. Means when, I mean, it's linked to the toReact function, right? But just creates a leaf element, empty props, I think. Uses get state to get the previous value. Uses get state to get the previous value. And passes that previous value Is this a kind of tying the knot thing? This is the previous value that's being gotten from space, and then this is what will take the previous, or the current value, and will push it down, write it. And this is called from outside. So, so maybe, yeah, indeed, this is tying the knot, but not only that, this is in fact doing the looping. Because when someone clicks, and then that value becomes a new state, and that triggers the rendering. So this is kind of this is a callback that is called by React when a button is pressed. No, that's not exactly that. This is called when, for instance, when React called onKeyPress and has installed a handler, then it has installed this callback such that when the callback is called, so user presses the key, then in fact the comonad will change. And this has installed a callback, so that when the comonad change, changes, then it writes a new state. And writing the new state will trigger rendering. I think. So if that's the case, then it means that we need to sort of manually tie the knot. We need to manually iterate over explore here. We can't just call it once. We have to then we need to be careful about I think so. It needs to be sort of run, where run will take W and we'll run W and your unit. Yeah, no, that's not the run we want. Runs an ST computation. Not that run, no. Hold on, did we have such a run elsewhere? Oh, we have that run, okay. Okay, so yeah, but yeah, what's the type of run? Well, actually, the type of run should be should be component console something. Explorer component. We could probably make it polymorphic, but let's do it like that to affect units, right? And so in which case maybe we just can let go. All right. That's the same thing. But yeah, doesn't work. I say it doesn't work, but we don't have any. We don't have any showing of nothing, nowhere. And we didn't have that even before, so I'm not even sure whether I needed to tie that knot or not. Huh. Interesting. I think we're going to blow up our computer right there. We already did, I think. Okay, let's reload this if we can. So, okay, question is, was it necessary to loop here? Okay, well, maybe strictly wasn't, but the fact that we do this set interval, we're actually doing this set interval at each iteration, and that's wrong, obviously. We really want to push that outside. You know what? Let's close that window. And let's drink a bit. Yeah, I think this particular choice of effect is, yeah, not the best. So I suppose the question is, how would we pass a kind of a handler? So we could run something like so. Can we view unit this? Well, no, not exactly that actually. What we want to run is more something like so, right? I think. Does this compile? I think it does. Okay, and but we would want maybe sort of before we do thing to register some kind of callback. That's fine, but we'd want a way to basically push inside this, which is what we had in our browser chronofold example. We got to push out of our top level attaching of things. So can we get something similar? And how would that even work? So explore is our workhorse here. And it does get past something that looks like a handler, but it doesn't return anything that looks like a handler. But I suppose maybe that's okay if we say that this is somehow like we say this is a listener. No, it's not okay, because we need to be called. So I don't think this works until we get something out of run that we can use to call, and that I think is send, right? Can we return send from Explorer? Given a way of writing, updating the component state within the base monad. So yeah, this is writing. But what does this mean? And when we say a component states, yeah, why does it need to be written? I mean, we know that with React, it needs to be written because that's what is going to be pushing pushing the state change that should, which I thought might be the thing that actually ties the knot, but I'm still not quite sure whether that's the case or not. But I think it has to be. Right, so if it has to be, then can we make it in fact such that our run function includes or returns some handler? With that, so that actually something is done. Yeah, maybe. Yeah, I think the fact that this is hooked to React completely hides the type of stuff that we would see around like basically hooking into the request animation frame, like the rendering loop. Like all of this is sort of hidden because the rendering loop interface becomes like this state writing interface, and then React sort of does its own thing. So you think it delegates all of the render loop, request animation frame, even handling, all of this through. This is quite impressive that but it makes sense because that's the essence of React, isn't it? That the state change is what triggers the VDOM rendering and the diff rendering and So now we make these concerns more explicit, and maybe we should take a look at Purescript grain right now, because I'm curious about how Purescript grain does because they don't use React, how do they do a Purescript only render loop? They have a VDOM. So it will be also state driven. Yeah, and I suppose this is a little bit more bare bones, but the idea is actually this is the way that this is hooked up to the DOM. Like the interface to the DOM is the state. And then the events, the JavaScript events, they're kind of, I think they follow, they're just callbacks. So that makes the whole driver thing like a little bit different. So I wonder, okay, now it makes me want to take a look at ChocoPie and how Justin Wood did this, and whether he had to deal with that concern or not. And well, he probably does, because this actually doesn't include a rendering framework, and so he does have to tie the knot somewhere. But does he go into defining how the render loop is going to behave, or is it just going to iterate as fast as it can? And does it even, what does it depend on? So in this example, for instance, the idea is to run chocopi main prime. And he does use an event data type. Yes. Events become the interface. Allowing subscription, and because the bot stuff is going to be asynchronous, sort of push in some sense. The ticks are going to be their own thing. But basically the concept is it won't, there's no not tying necessary for the main loop, because everything is event driven. So the main loop actually just gets forward only when an event is received. So that's something where we could wrap, I think, around explore, or maybe as the writing thing. Maybe would that work as the writing thing? How would that work? Receiving an S would push, or or I think we need to wire events like deeper. I mean, could there be a base monad, a driver monad? Could we make this event something? This is always binding, a little bit mind-bending for me, how to think about the wiring of this type of system. What it looks like at the boundary and then what it looks like inside is very different. And event is something I think I also haven't built enough intuitions on. So, but I think it's worth taking a look at frp.event in Purescript, because yeah, I mean, this has been extracted to Purescript event, and it does have the fixed point thing. I think there's no example, if I remember correctly, unfortunately here. Yeah. But there's this idea of sampling on specific events. And an event is just a value at an associated time. Those are the FRP events, right? I just need to double check. I know that I've seen these before, but yeah, it is FRP events. And that's arguably the tying of the knot, I think. Not even sure. This is still type level wizardry for me. Okay, there's this really much simpler example right there. A waveform's event unit ignores it and returns an effect of event end. So that just creates an event and that just creates an effect. Whereas this waits for an event end and returns an effect unit, and that's the effect unit, and then those things are just wired to each other, starting with A as memty and then passing the source of A into B. Okay, how do I make progress here? I think that is correct. My sense that this needs to have an event loop, I think it's correct. In order to make that event loop contain this notion of subscription or callback, that I don't quite know how to do. But is it just the same idea of iterating over a melee machine? It might very well be, and it might very well be pretty much the same as Reactimate, basically. So when we do unfold co-free here, we iterate one step only. And this, or explore, also iterates one step only. But can we see it as threading? So here it's passing a unique carrying thing. That doesn't make a lot of sense in our context because we passed the whole monadic value, or comonadic value, which is like the initial comonadic value. But then here it just runs indefinitely in a tight loop, which is what we're doing here. But we don't allow here anything to occur sort of in between, right? But if we did something like given an S, you run less, but you also maybe show some stuff. That could be a thing, but so that's not going to allow us the spirit apparently of Explore is just to write some state into some other framework that's kind of responsible for maintaining state. So such that which is really the actuator, I'm pretty sure. But then the sensors, I think, are kind of off band. They don't get nicely written here, as contrary to the FRP implementations. They're ad hoc. They're put ad hoc in those event handlers. So okay, now I think I'm seeing something here, because the reason why they put into these event handlers is that we don't wire them with an input and an output. There's no real concept of an input and an output, at least in this formulation. But it's not like we couldn't do that. So in this context, if we say this is an input, and instead of being defined in the midst of the component, that we say, no, on-key press is defined outside, then it would be, there would be a sensor, and we'd wire in on-key press, and then it would send an event through the component network. And the components would take on that event and know what to do with it. And I think we can still do that. I mean, in fact, in this case, it's not even clear whether there's a need for the component itself to do that. There might not be. It could be that the sensor wires the on-key press event. Then there's a way to wire the result of the on-key press event to some monadic effect, some monadic action. And then this monadic action is passed to the interpreter. How is it passed to the interpreter? Here it's passed to the interpreter via send, but send has really no business being inside here. I think it's really an accident of this particular formulation, the attempt to make it work with React or make it more React-like. But this send here, or this send here, comes from the driver, or in our formulation here. The question is what is the input of the driver and what is the output of the driver here, right? Because here our driver, first of all, why is our console component, where is our console component's definition a driver? Well, probably because actually usually a console would be a driver. So there's a bit of a, we need to rewrite this. So let's think about it. So let's see, this is this would be maybe whether not even a timer component, that doesn't work. We want some application logic here, and we want the drivers to be providing some inputs. So it's not sufficient to have something like this inside our component. we want some application logic in our interpreter somehow. So but it could be that we also want our drivers to have some of this regularity and use these primitives. Maybe that's also part of the business here. But let's call this uppercase component and start simple. And maybe we have a driver that does something like this. And maybe in fact, you know, we pass our driver. We pass some kind of driver to our component. Driver. And if it's uppercase, then does it send things? Well, hold on. If it's uppercase, then is this really the driver? It's not. It's uppercase. Hold on. What is an interpreter in this case? Do we even have one? Or do those live only in the drivers? In which case, unfold cofree might happen also outside. Our applications should be receiving application related events those might be translated. So there might be an interpreter on the way in and an interpreter on the way out, like a sensing interpreter that takes the driver inputs and transforms them into application events, and then our application events transform into other application events that are then mapped to outputs. Or interpreters are really only for the lower layers and the drivers, and our application directly takes sensing events or sensing monadic actions that exist, that are declared in the driver layer, and produces the same. And so in which case there are mappings of input monadic events to output monadic events. So then the whole free co-free business happens in a driver layer, and then up is only pure, and it's only monadic events. Basically stream combinators. Which works with the Cycle.js way of thinking about the world, which also seems to work with kind of an FRP way to think about the world. So uppercase component is not a non-focal free. Or focal free would occur somewhere outside while we run. Uppercase component wouldn't be a component that looks anything like that. It would be more like something from, well, yeah, there is a question here, or maybe there's two ways to think of it. Whether is it a mapping from, is a component maybe a mapping from a stream of events, a free monadic action events to the same, or a mapping from a stream of comonadic state spaces to the same, or some variation, or the combination of the above as input outputs. And are these different things? Because it seemed we could do all of that actually. Maybe. No, I don't think that makes sense. I don't think that makes sense. I think the real model is this. Because if we need to go into comonads, then we have to have applied explore or have done some kind of pairing already. So these things it might be that those represent layers. It might be that at the like that upwards of here is some kind of component layer, and that downwards we might have like a state layer or a state space layer, which would be that. And then maybe in the middle we could have these combinations. As basically sort of source transformers or sink transformers or something, maybe transducers, probably they're transducers. No, I think that's probably their own thing. Adapters, let's call them. It's abstract enough. It might be useful to do some things in the space layer, like particularly things like actually dealing with state serialization or traversal or like loading and storing. Could be that that's the best to do at that lower layer. Then dealing with actions, then it seems like that's where you want to be. No, I think I might be actually, well, maybe. I think I'm confusing like the comonatic nature of this, well, what was called component in Purescript React Explorer. With the role of the interpreter aspect of them and the comonatic nature of well, I suppose you could say state, although state is not itself a comonad. No, I think there is, you can, even though store is the pair of the state monad, I think there is also a state comonad, which makes things more complicated. But it's not about so much the interpreter side of things. And I think I haven't reconciled necessarily in my head what the intuition that connects the more interpreter nature of the comonad pattern functor with what I understand as comonads as the spaces. But maybe I do have the correct intuition. It's just that I suppose my intuition of comonads as interpreters is that the interpreters define the way to move through the state space. So they, by extension, represent the whole state space and it's all possibilities of the state space. And I suppose when you look at comonad for storage or like index data structure or zippers and whatnot, then the focus is on something slightly different. It's on the interfaces and how you extract and focus on different aspects of the data. But it's just like there's an orthogonal view of like, okay, sure, like you can focus on where you are or on how you move to one point to the other. So I don't know whether this is going to be helpful at all for how to deal with state and state loading and storing. So will there be some impedance matching with store load focus style comonad? And then at the component layer here, we can assign, we can be either pointwise or streamwise, I think. And we can probably choose. And so then that would mean that uppercase component would, like a component, we wouldn't use anymore these definitions. That would be something else. It might be a driver, in fact. And then we might push what a component is inside just simply what UI was. And that will be pure because we won't need anymore to do either effects in it or to care about the returning of a monadic action in them, because that would be their main purpose anyway. They just transform monadic actions into other monadic actions. So console is the wrong example. We need another example, and that would be something like what? If we do uppercase, then really we're talking about word as the type and as the base monad. And so we're kind of saying coword is coword, coword f is coword f of word, which is just a tuple of some string to next. Just carries a word in that string. And I mean, I guess there's also a question about whether we want to define this as a pairing, but yeah, somehow I think maybe we do. I'm not sure why yet, but yeah, right, so we define a function instance for that. And then we'd have like some type word, which would be the monadic version of things, such that so interesting. I think this is helping me clarify stuff. It's the get side of things that we want. So wordf would be co wordf string, and it would only have one way to go. And then word would be word string or unit, I suppose. Right, that's interesting. Yeah, what does it mean here? Let's do word unit. And there would just be this, right? Wrap free wordf. Right, that's in the case we wanted to construct one. Then be constructed. So that seems like we probably don't need that at all, but I need to get there in order to understand why I don't need it. So our driver can be that if we want, but then our uppercase component would be what? We would be, I think what I'm trying to get to is something from word to word. But so if I have a W, I have a word unit, can I extract the str from it, right? And what does that mean exactly, right? That means it's like from a, so it does mean that I want to kind of unfold co-free, maybe. Maybe? What? This feels strange, but yes, I think I do. And there's some action. I'm taking an S to a co-free effect. Am I? No, I don't want it. No, so no, I'm not doing that. Oh, okay, hold on 1 second. I might, but then it means that the output of the co-free FA, I want to transform back into an action somehow. So I want to wrap free it. But by the way, a word to word doesn't mean anything, right? It has to be a word unit to a word unit, maybe. So if I go with this approach, then what do I do? I mean, it seems like a whole bunch of work I actually don't need to do. But then what would that be here? Here there would be some way to the actual transformation. So let's call it transform. And then here, I think it will have to be an interpreter, but the trivial one, which is kind of a little bit like that one, but I suppose if there's kind of an identity interpreter, it's sort of the one that okay, let's see. Word word interpreter. So does this really have to take a string in output? I think in our case now it would take a unit as an input, which is okay, why not? And then it will return a wordf unit, and that would be something where we take the unit, we take whatever, and we return a wordf with in it word tupling what exactly? Just unit and unit. What? That doesn't make any sense. So now we don't have. Okay, I'm exploring now. I think the relationship between the carrier type and oh, you know what? Is that what I need? A kind of combination of put and get somehow? For some reason, I just had a thought coming to my mind that I'm reinventing lenses. Because this is a pair of a... It's not a pair of a setter and a getter. No, it's something else. But it's a pair of a producer and a consumer, maybe? Oof. I am wondering, wondering about in the space of possibilities, learning at the same time. Hopefully. Okay, is that really what I want to do? Why was my intuition to use this get? Because get sort of implies that you have access to it somewhere. But put implies no, you don't have it. We need to get it to consume it from somewhere else. And but if you've consumed it from somewhere else, then you might not have it anymore. You need some way to get it out. So that's, I suppose, is a setter getter, right? It absolutely is a setter getter. So here I'm trying to bundle the setter and the getter together, and that's a lens, isn't it? So and that might be the stupid formulation of a lens, because that is indeed a setter, something that takes a string and kind of continues on. Okay. So in that case, it kind of means just states, and that's, I think that's supposed that is correct. It feels overkill for state, but maybe we will gain something from doing it that way. But then wordf is not going to be this, because second now needs something, but also it means that we kind of need to pass it something. I'm really not sure whether we are going to gain anything from this, because I mean, where we sort of want. Okay, I suppose let's try it. It's an interesting learning thing. So we're now passing a string, and instead of doing second word here, we also put str unit into it. Well, really, in our case, we put str that's what we do, I think. We get the current word from the first pair. So maybe we don't need to actually set it here. Maybe we just pass what's in here to the next thing. So the type of this is going to be wrong. Is it? Because I think co expects there's something that returns an R. It's not going to work, right? I mean, what would this look like? A word interpreter? And why would it be unit? Be unit in unit if we consider that we wanted to decouple ticking from managing state. But so in that case, next would always be a ticking thing. It's actually kind of, it's possible, in fact. And so word interpreter then would be what? We need to get it a string. Can we get one out? No, we can't. We can't create the comonad out of thin air if we don't have some data. If we were past the comonad, then that would be another. That'd be something else. So I think, yeah, I think I'm getting. I think this comonads don't have to play any role here. Is basically, I think, the result, or somehow, is that the monadic value should carry a string, and that should be enough. But I suppose it would be so because it will be passed somehow. Would it be passed by the driver layer? I suppose it will, right? It will be something as like the result of a put. So if the driver layer somehow results in some kind of put action occurring in the driver layer, and we have it put I wonder if I did this in the right direction. Because if, yeah, the problem is that there's all these multiple layers. I think I need to do another layer diagram here. Yeah, I suppose one question is, when we're wiring the world side effects, are we doing this with a monadic interface or comonadic interface? And does this even mean something? I mean, in truth, it'll be something like a callback, right? Be something like we receive something from an IO value and we convert that into what? Some kind of monadic action, I think. That would be the okay. That would be the sensing part, and then the actuating part would just be monadic values. And so then is the interpretation going sort of upside down? I mean, meaning is it that then we transform the monadic value come from the bottom into commodity value more like at the top? Doesn't even make sense. I'm starting to question my the sanity of my overall intuition of what's the usefulness of this approach right now. That's good. Doubt might be the moment where understanding emerges. I've always thought of interpreters as the thing that carried the effect, such that monadic values moving in the applications would, at the bottom, be interpreted as side effects. But here, the thing that came naturally to me is not that at all, right? So, so I mean, there is a lingering question in my head, which is this a case of you have sort of like comonads and then monads and then comonads and then monads? Is there something like that going on? where you have like real world events and like some kind of interpreter of real world events into an applicative events somehow, back and forth, and even that back and forth aspect actually somehow carried by that whole abstraction. I think it's not, because when I was doing the play stuff, the back and forth aspect were done through these request types that were able to go, that were bidirectional. But I suppose also we could say that things don't have to be bidirectional. It could be that there's something like a channel that goes up, and one that goes down. And that one has monads at the bottom, some monad, and then some comonad, and then a monad. Who knows? I don't know. Just trying things. And then here maybe there's another channel in which you have again some stuff like that. They don't need to be connected. They might be. And so you have sort of, in this aspect, then you have sort of input monadic events at the bottom. And then some output monadic events right there. And then maybe they join at the top in work some comonad, maybe. And is that the components? Or is it reversed? And does it even make sense to talk about them as monad and comonad? Is that really the point? The fact that state to store is React, does this mean that there is an untold interface between the comonadic nature of the component and then the state-based interface of React? And then when there's an example with store, for instance, then is there a direct mapping between then the store modification and then the state modification at the React layer? Or does this even mean anything? I think it does. But here the difficulty maybe, or in some sense, I mean, there's a couple of difficulties. One is that then the state monad doesn't feel very like monadic actions, like maybe that's wrong, like because a monadic value is something like modify state or put state or get state. That's the APIs that state offer. So those are monadic values in their own rights. Except that in this case, if the interface with the bottom layer React is state, then arguably yeah, I mean, the question is, okay, let's put it in here. React state. And then here the component store. Is there something here that's more like a component state, so to speak? And is that when we do modify at one, is that occurring here? Sorry. Then gets translated into the monadic action through explore, and then this through to React gets also somewhat translated into something that feels monadic as well. Plus the additional complexity is that this seems like it's only the, is it the downward one? The downward channel? Yeah, it is the downward channel, in the sense that the monadic action occurs at the top, and but that the wiring of the upward stuff is a bit of a the upward direction is a bit short circuit kind of thing, because in fact the P on click, for instance, right there, that's really directly a React state or React primitive, and we just could short circuit that pretty much all the way up to here, where we just say yeah on click, and then we have like the send thing, which creates this monadic value. Oh, but it's not. That's maybe the symmetry that I haven't seen. Like this uses the modify. Okay, yeah, I suppose that's the question, is where is this modify coming from? Is it from, it looks like it is from state, and so then it would be the pair from the store T instance, and then piggyback on the instance, the pairing instance between store T and state T, and just be able to work it out. So that's fine, and then it still really in truth gets pushed down to a monadic value, and then from there pushed down into an actual React state. So there is a mirroring effect. Does this work well because well, no, of course, clearly it doesn't work well because there's a mirror between this component state and component store. Why? Because we have co-free and trace the example running into the Purescript React thing. So it means that that top layer can be replaced by another pairing. And it just happens that then it becomes a kind of an adapter, which feels like it's, or does it? I mean, one way to see it, I suppose, is this really kind of exploring these guys in some sense? And are we really kind of composing transducers somehow? I don't know. This is hard. Oh boy, this is hard. Yeah, basically, is the fact that there is an explorer okay, I need to refer back to the original code here because I'm there is a React Explorer and there is a React UI. So yeah. So this is part of the original thing. Just have state and a function taking each state to a user interface. Yeah. It's similar to it, and then somehow at the bottom, right here, explore wraps an explore. And so that feels like that's some kind of transducer or some kind of adapter. The fact that it's also called explore is a sort of a hint for that. And it's just like the way that it does the adapting is by just writing the whole comonad in state. Obviously, this is not the state monad necessarily, but you know, React state is not the state monad. So that's another thing to consider in this whole. Questioning. Because you would be expecting then, if it was really something where you go from kind of monad to monad, that you wouldn't just be storing the whole monad, the whole comonad inside your monad. That feels like that's kind of wrong, so to speak. Wrong in the sense that maybe what I'm what I've been rambling about is not right. Meaning, but the other way to see it is like, is this a state monad right there? Like a opaque state monad. But if it's, even if it's an opaque state monad, like why would we just write the comonad in there? That sounds like we'd want to sort of, if there was a real symmetry here between the upper to the lower, then we need to transform the comonadic value into a monadic value again. But intuitively, you'd think that maybe you could. That maybe the fact that it's opaque might prevent you from seeing the pattern, but here you add 1. So you are modifying state. So if you did reflect this lower down somehow into something that was less opaque, then maybe you could reconstruct the add 1 below. Why would you want to do that? Not sure. You know, but maybe because you have a tree of component up there and this is your aggregate state, and you know you want to do serialization lower. But then why do you need a comonad as an adapter then now in between those things? Let's go through maybe the slides again. Okay, so for in this approach, the comonad appears from recognizing it. Oh, sorry about that. I'll take a quick break and close the windows and put on some layers. Be right back. Okay, so comonad appears from looking at the counter. Whoopsie. Okay, so in this context, we see this as part of a driver somehow, right? So this doesn't necessarily matter. Suppose here, right? Okay, so initial state and then rendering take some model and return a VDOM of the model. And so you see a comonad there, specifically the store comonad, which carries the model and returns something that depends on the model but returns the VDOM of it. Extract renders the component current state and duplicate capture the possible future states of the component, returning a store full of components that are all possible future states. That's fine. So how does this apply here? We're saying our store component here represents all possible future states, or that we represents a component in such a way that we can extract the current state and that we can model all possible future states, such that we can move through the state by being given one such monadic action. And so that's all good. And is this accidental here? Look below. Made a function explore. Which takes a future and returns the current thing. Maybe it's a step, I think. Really step. But they said to usefully implement it, we can read the current state and move to a new state, which can be packaged up using the state monad. So here, I don't know. What I'm hearing is, I'm hearing the bottom layer. I'm hearing this guy reading the current state and moving to a new state. But packaged up using the state monad, that now when I hear that, then I hear this guy. The premise is a useful implementation of Explore. The definition of Explore is not necessarily given here, but I think we know Explore takes current comonad. Well, really, it needs to take on an action too, right? At least this version. Oh, this version says giving a way of writing, updating component state within the base monad. But this is from, is this from the original? It's not. In the original version, this is done in one fell swoop without the decoupling. But it's getting the state and returning something where passing the current state, which in this case is the comonad, which is troublesome, but and send, where send will take an action. So now with this taking an action, so this is what I guess what explore has defined up there. I defined the slides don't really capture necessarily. In fact, the type is completely different, right? It's from a component to a React class. So now we've mixed the concerns. Some component W, this is an actuator, right? This is from current component to the next. But in fact, embedded inside it, it's true, there is how you actually do the actual explore. So maybe in that sense, this is better, because this does separate the outside explore wiring with React from the inside explore, which is really only getting some way to write and the current space, and then now it knows how to go. And the way to write is here defined in terms of component T base W, but I think we lost something. No, we haven't, because it's part of component T. So, I mean, it's part of component T that it takes a base action, and we know what the dual or the co of our comonad is. So has this been somewhat hidden by this type signature? This says that given a base value, this says that given a current component and a function to write a base component, I write the next thing. But again, I think this is accidental. I think this whole write business is because in this case you just happen to be needing to write the React state out there. But there's the fact that there's no read is a smell somehow, right? Because the read is this whole event, this whole on-click thing. That's read. I suppose this is right. And explore a status space is a space of states specified by some comonad, defined by value in that comonad, and it creates a React class which can be rendered using React. Yeah, so this is obviously compact, but it also doesn't really correspond to this explore right there. Where does it correspond to? Something that takes a duplicate, but we don't, there's no real use of duplicate right there, right? Even in the original formulation. Let's extend. Explore here takes a pairing, a W of the UI, and then returns an effect unit. This is the original gist. And the Explorer used duplicate right there. Because this is duplicate. The store model component, that's the result of a store of model component is the result of passing components with duplicate. So originally the thought was the notion of explore is to somehow narrow down the state of all possible future to one possible future, but and then somehow the idea is that this is related to the concept of reading the current state and moving to the new state that relates to the state monad, and that's the implementation. It takes this current state in the store, and so it feels a lot like this is where the pairing is heading, which is really confusing because it's kind of like the implementation that we see. It looks like the implementation of that bottom layer right there, right? Oh boy, okay. Here. No, in fact, this is pairing, I think, which makes things more complex, more confusing too. This is pairing, I think, meaning this is indeed this is how indeed the actual state monad will combine with the store monad. But then that render, then this is we're back to below now. And then this is the read. Get paying for free. Huh. Here handler was a co of W and units for some reason. Interesting. Why is that? Here handler F state react state read write. Also it's back in the F times. So that doesn't look at all like the handler. Let's close this. Yeah, so and then the deconvolution. And the beautiful mathematics behind it. And linear lambda calculus. Right, supposed to be the internal language of closed symmetric monoidal categories. Ed was saying this. Oh boy. So to me, it looks like then if this is right, if I'm not completely out of my mind, then there is a kind of an adapter pattern hidden in there. And then the question becomes, well then, pick up this state and then I put a command underneath. And saying that this is right is also probably not exactly correct, because there's obviously something more going on right there, or something that maybe can be abstracted. I mean, and also that yeah, the lack of symmetry here is also troubling. It's troubling, and it really also makes me think that there was symmetry there, though, in the using Purescript run streaming, because of the bidirectional piping inclusion. But it doesn't mean that I solved with that the problem of inputs and outputs. In fact, I hadn't. I was stuck, and implementing the actual effects as a carrier type for the comonad also felt like unsatisfying. So is there a case where because now side effects are somehow hidden in kind of this opaque layer, but this explore the React version of it, and let's actually go to Arthur Xavier's implementation for this. And in fact, let's even check out and compare with the other one, the RSS one. Okay. UI to do RSS one. I want to take a quick look at this. this has an explore as well. Interesting wording here. It's not called send. Oh no, it is called send, but instead of being called base, it's called transition. He used the extend version, whereas here it's called base. I think that's because there wasn't a base monad anymore in this, right? Component here had base WMA. The component has MWFA. Yeah, so there's some trouble right there. Also because here M monad and here a base monad, okay. So it was properly updated, but okay, I mean, this feels like an interpreter. It's an interpreter in the base monad. But I suppose there's something that's unclear. If we said, okay, this is right, then we know how to interpret monadic events into comonadic sort of state changes, but do we know how to interpret comonadic state changes into monadic thingies, values? Because we don't do that in the UI thing. We just persist the whole comonad in state. Which feels completely wonky to me. I don't. This feels like it's not pairing. It's not explore, it's pairing. Meaning, in the example, this is done via not even is it done via unfold cofree? It's not really, right? What is it done with? It's done with sand, is really what it is. And I suppose explore has a sand, but it's not the same sand. This sand is not this sand. This sand is the handler. Which here took any A and return something in the React state. Holy moly, but then if it's in the React state, oh, is it just tracing? Then this is the co-store, but then sending the co-store then gets to, in the end, activate React state read write. So therefore, it needs to have React state read write as an effect. That would make sense, I suppose. But this send, it does look curiously like this one, but it's not. It takes an M unit, like an actual monadic value, which, by the way, also is weird because indeed at some point we had action to base units instead of base action to base units, and so now there's a friction between these two. Is there confusion with these things? Or is it just that in fact there is some kind of symmetry and repeated pattern of how in fact sending something from the top layer, meaning by the top layer I mean, okay, let's go into here. So sending something here with a handler just happens to resonate with then how later through this thing, the writing and the send somehow start to look a lot like the handler here. And this kind of makes sense because this is the boundary between the effects. So could even put this here, right? Possibly, if I wanted to. Maybe we'll make the pattern more visible. And so if it's, so those are then, yeah, like there are definitely connection of like receiving some event from the outside world and then writing state to the outside world. But obviously this one could be called receive, and this one send, and this one read, and that would make the symmetry more visible. So this could be, yeah, if this was receive, like it would mean like if we receive something then we modify, right? It's the receiving channel. Or so it could be if this was read, Yeah, it wouldn't make a lot of sense. But or a weight might be another pattern there possibly, and then yield here, right? Which then sort of maybe shows the transducer more like aspects of it, or at least coroutine, but I think those are transducers. Interesting, because if there was read and write as opposed to read write, no, but this does use read write as the state. But this modify here, does it even need to be in read write? You know, I get the feeling that it doesn't. I get the feeling that this is not needed for some reason. Because the modifier we send here is the pairing, right? Modify is gotten from control monad state, and that's not this. That's handled with read state and transform state, not modify. So modify, not enough, I don't think. In fact, it's pure, and so it doesn't need to be enough. So has this been a misunderstanding all along? I mean, because here there's this base in the original stuff. I mean, yeah, no, this is all my modified stuff. But originally here, it's also in base, and yeah, base is supposed to be. So maybe it just doesn't even need to be in base. Can I test that? Can I just remove base? Doesn't even need to be a handler. Okay, how could I test this? I think I could. I need to remove a bunch of stuff though, so that it recompiles. And we need to remove this. And I need to remove not the where, this, and oopsie, and then local state also can't be there, and console component is not here. Yeah, that's right, because I don't have such a thing anymore. Did I delete it? That's not smart. Should have kept it around. I think that's what it was. It was the console component. That was this. But let's reactivate co-free React by activating that and commenting that. And still some error. Yeah, because driver is not a thing. And here, effect unit with unit. Sure, yes, because we're now trying to do this, whereas this whole thing can be actually commented out. Yes, it can, and then we can run test and localhost. And then we can try that thing of saying, well, handler, we don't use handlers anymore. This is just in base action. And in fact, it's just action. That's okay, fine, let's say base action. So now no more handlers. Is that how we want to do this? Yeah, why not? So now send. What is send then? Component T has gotten simpler. Here, this has no reason to be a handler anymore. It's just going to just be base. I think. If that's the case, then we don't need a base. We just take an M and write. And then in that case, writing sure can be in base, that's fine. Function code w1 unit. Right. So that's supposed to be waiting for NAM. Okay, you know what? I'm going to write this down as an exploration for next time, because I am totally running out of juice, and we can write it down. So, how to design effect for interpreters. I suppose we're still on the way to trying to think about that. And so is it correct that there's no need for the handler type? The intuition being that we would then that the send callback that is basically a handler already. So that basically that UI can be just a function from action to react. And then some of the other wonderment of today are yeah, maybe we should even put that before, but there's some kind of symmetry between this send. Yeah, no, I want the gist between this send and this send, but they're actually not the same. Which receives an action that's not this, which transforms an outside event into a monadic action. So when it's written like this, send modify add 1, it is partially applied on an A. And I suppose that base monad is just the constraint. It is actually correct. We can't remove it. It is just a constraint of the fact that we're intermingling these UI display concerns and these event handling and monadic action concerns. So, meaning, in fact, there is a need for, maybe there is, I mean, there's a need for that base monad, but yeah, no, I suppose there is a need for it. So, no, it's not correct. Because in this approach component wraps UI, which is probably poorly named. This is sort of UIs. It's like a set of all possible UIs. Although it's not the comonad, it's still waiting for comonad to show up. Yeah, the store T, right? But still, it will be wrapped, it will become a comonad full of UIs. And these are really, it's almost like a UI stream, in fact. So maybe this whole naming scheme needs work. This is not component T. Component W for the future UIs. Why would you call that a component, right? Component feels like it's a small thing. It feels like it's a small part of a UI. Usually that's what a component is, whereas this is so much more, right? This is all, this is the universe. Or space. And actually I've commented out, I think, some of my new stuff. But this, then it means like my console component, I think, would have been a state of console units, I think. And space. Fine, but then having these spaces, we need to explore them. That's good, exploring spaces. That works better than exploring a component. But we don't iter them. There's no main in here. Right. I'm trying to look at the symmetry again. Yeah, this extra driver thing is probably not needed. No, it looks like it is. Because the UI is a handler to React elements. It seems like we do have to pass this handler if we want to be able to hook to be called back. So no. So no, because we need to be called back with need to be called back and then this is accident. It shouldn't be polluting things. But the monad in which we get called back, React blah blah, is accidental. We should really be focusing on something that we should decouple the part that's reacty from the part that's interprety. And so when we interpret, then really we sort of install a listener, or we kind of we subscribe, or we install a listener. Yeah, we should think of it as installing a listener thing that goes from A to co-W unit, basically. Yeah. I think that will clean things up quite a bit, I think. Then we can push. Maybe then that allows us to sort of refactor things inside the interpreter. I don't know. But that's where I'll stop. This is already totally blowing my brain. But I think this is right. I think this is probably one of the important results here. I think tying the handler to the wrapper is something that can be disentangled, so that in fact the handler just goes to co-W unit, just creates an effect, a monadic value that we need in order to know where to go next. But then we don't need to then we can just make it pure there to be in the right monad or whatever, or some other trick in order to make React happy. But I think this will help. might even allow us to get rid of some of the base monad. Maybe it could be that in terms of spaces, I mean, it's obviously a little bit. Now that I'm looking at this name a second time, I'm like, okay, I should. Yeah, I'm going to write something down. This last thought. Do we need to specify two types of spaces? And I suppose I will. Oh, damn. That's a mistake. Come on. What's up? Why can't I? Oh. Okay. Oof. That was worrying. So do we need to specify two types of spaces? One for drivers and one for widgets. And I suppose then the other question is, can we stack? Can we really stack make monad, comonad sandwiches? Towers. Is that a thing? Connected to this question here, right? And this question here. So let's put this in the log. All right. That's it. I feel I've captured it. Better to document this a bit more in depth, especially because I'm supposed to be switching back to Haskell next week, so it won't be fresh in my mind when I get back to it. So having some docs will definitely help. All right, that's it for me. Thanks a lot for watching, and I will see you next week. Bye bye.